Hello everyone, in this video we will learn how to find the local maximum and the local minimum values of a function if it exists using the first derivative test. And let us go to the first example. Here, if f of x equals x power 3 plus 3x squared minus 9x minus 7. Find the local maximum values or the local minimum values of the function f. First, we must consider the domain. The domain of the function f here is R, and we write it. The domain of the function f equals R, where R is a set of all real numbers. Okay, and also f of x is a continuous function. Now we will find the first derivative. We have f of x equals x power 3 plus 3x squared minus 9x minus 7. Then we find f dash. F dash of x equals 3x power 2 plus 6x minus 9. Then we find the values where f dash of x equals 0. So put f dash of x equals 0 here. 3x squared plus 6x minus 9 equals 0. So by taking 3 as a common factor, we get x squared plus 2x minus 3 equals 0. Then we factorize the right hand side. It will be 3 multiply x minus 3, x plus 3 multiply x minus 1 equals 0. So putting x plus 3 equals 0, we get x equals negative 3 and x minus 1 equals 0. We get x equals 1. So there is two critical points when x equals negative 3 and x equals 1. Okay, because both negative 3 and 1 belongs to the domain of f, belongs to the domain. So negative 3 and f of negative 3 is a critical point. Also 1 and f of 1 is another critical point. And we calculate f of negative 3. So negative 3, and we calculate it for x equals negative 3. We get 20. And 1, and we calculate the value of f of x when x equals 1. Calculate for x equals 1. So we get negative 12. So negative 3 and 20, 1 and negative 2 are the two critical points. Now we're going to make a table to determine the intervals where f dash of x is positive or negative. Actually, we wanted to determine when the function f of x is increasing or decreasing. Okay, so I'll draw a table. Here we have x, f of x, f dash of x. Here we have -3 and 1. Okay, and we check for some numbers belongs to the interval from -infinity to -3 in the neighborhood of -3, and you can check for x equals -4 here. Of course, when x equals -3, f dash of x equals 0, and when x equals 1, f dash of 1 also equals 0. And we write f dash of x here, f dash of x equals 3x squared plus 6x minus 9, and we calculate for x equals -4, and it is a positive. Okay, so f dash of x is positive here in this neighborhood of -3. So f of x is increasing, and we choose another number lying between -3 and 1, like 0, and f dash of 0 is negative. Here f dash of x, when you substitute x equals 0, you will get -9, and here is negative, and the function is decreasing on this interval, and we take another number greater than 1, like 2, and we substitute in f dash of x. So we calculate for x equals 2, it is greater than 1. Also, it is positive, so we write positive, and we deduce that the function f of x is increasing in this interval. Okay, so before x equals -3, the function is increasing, and after x equals -3, the function is decreasing, and at -3 there is a critical point. Then you can say that the point -3 and f of -3, f -3 and the 20 is a maximum local value, is a maximum local value. So you can say that the point -3 and 20 is a local maximum value for the function. And since the function is decreasing before x equals 1 and increasing after x equals 1, you can say that the point 1 and f of 1 equals -12, is a local minimum value. Example 2, find the local maximum and minimum values of the function f of x equals x power 2 over 3 multiply 2x minus 5. So since f of x equals x power 2 over 3 multiply 2x minus 5, then the domain of f equals r, and we will find f dash of x. F dash of x equals, here we have the product of two functions. Here x power 2 over 3 multiply 2x minus 5. So to get the first derivative, we write the first x power 2 over 3 multiplies the derivative of the second, which equal 2, plus the second 2x minus 5 multiplies the derivative of the first function. The derivative of x power 2 over 3 is 2 over 3 multiply x power 2 over 3 minus 1. And we arrange this. We write 2x power 2 over 3 plus 2 over 3. Here multiply x power negative 1 over 3 multiply 2x minus 5. And we write 2x power 3 power 2 over 3 plus 2 over 3 multiply 1 over cubic root of x multiply 2x minus 5, and taking 2 as a common factor here, 2, we get x power 2 over 3 plus 1 over 3 1 over 3 multiply, here we have 2x minus 5 over 3 multiply cubic root of x. And then we must add these two fractions, these two parts. Here we have 2 multiply, here in the denominator we write 3 cubic root of x, and then here we have 3 cubic root of x multiply x power 2 over 3, it is equal 3 multiply 3x, okay, plus 2x minus 5, and we simplify it. It will be, here we have 2 multiply 3x plus 2x, it is 5x minus 5 over 3 cubic root of x. Then we'll take 5 as a common factor, so 5 multiplied 2 is 10 multiply x minus 1 over 3 cubic root of x. Now putting f dash of x equals 0, we get, here is f dash, don't forget f dash of x equals 0. So we deduce x equals 1. And also f dash of x is undefined when x equals 0. Okay, here f dash of x equals 0. And f dash of x is undefined when x equals 0 because x in the denominator. Here x not equal 0. Okay, so f dash is not exist when x equals 0, and the f dash of x equals 0 when x equals 1. Both 1 and 0 belongs to the domain of f. So there is two critical points when x equals 1 and when x equals 0. So 1 and f of 1 here is a critical point. Also 0 and f of 0 is another critical point. Now we calculate f of 1 using calculator and we write it x power 2 over 3. Okay, multiply 2x minus 5, and we calculate for x equals 1. So the result equals -3. So 1 and the -3 is a critical point, and we calculate for x equals 0. It is equal 0. So the point 0 and 0 is another critical point. And we put it in the table to check when the function is increasing and when the function is decreasing. Like this, we draw a table here for f of x and f dash of x, like this. Here we have a table here. Okay, for the 2 points here we have x, f of x, okay, and 0 and 1. When x equals 0, f dash of x is undefined, and when x equals 1, f dash of 1 equals 0. Again, when x equals 0, f dash of x is undefined, and when x equals 1, f dash equals 0, and we check the sign about 0 and 1. We'll take numbers less than 0 in the neighborhood of 0, like -1, and we check for -1. Here we have f dash of x equals 10 multiply -1 minus 1, it is -2. So here we have the numerator will be negative, here negative, and also the denominator will be negative. Negative divide negative is positive here. So the function is increasing in this interval, and we check a number lies between 0 and 1 here, like 0.5. and we check here. So when x equals 0.5, the numerator will be negative, and the denominator will be positive. Cubic root of 0.5 is positive. Negative divide positive is negative, and the function is decreasing on this interval. And we check for x greater than 1, like 2. If you take x equals 2, so I'll check for x equals 2 will be positive, because 2 minus 1 is positive, and here is positive also. So here is positive, and the function is increasing on this interval. So the point 0 and the f of 0 is a local maximum point. We write f of x equals x power 2 over 3 multiply 2x minus 5. Here is 5. Okay. So f of 0 equals 0, and f of 1 here, f of 1 equals 1 equals negative 3. Okay. So there is a local maximum value when x equals 0 and local minimum value when x equals 1.